Now we'll start 3D geometry. Now in 3D geometry, we'll have three axes which are mutually perpendicular: x-axis, y-axis, and z-axis. And as we can see, all these three axes, they are perpendicular and they intersect at origin. This is 0, 0, 0. And they have divided this entire space in 8 parts, which we call octants. So there'll be 8 octants in case of 3D geometry. Now, any point on x-axis, say this point A, it can be expressed as x, 0, 0. Any point on y-axis, say this point B, it can be expressed as 0, y, 0. And any point on z-axis will be taken as 0, 0 and z, and say this point is C. So if you have to take points on axis, then this point A will be x, 0, 0. This point B, it is on y-axis, it is 0, y, 0. And this point C, which is on z-axis, it is given by 0, 0 and z. Now, if you look at this plane, it lies along x and z. So we call this plane as x, z plane. Now in xz plane, y coordinate is always 0. So equation of xz plane will be simply y equals 0. Now this point, say D, it lies in xz plane. Now for this point D, this is x, y coordinate is 0, and this distance is z. So coordinate of this point D will be x, 0, z. Now in the same way, here we have this plane, and this is nothing but this is xy plane, and equation of xy plane is z equals 0. So coordinate of this point, say E, will be x, y and 0. And finally we have this plane which is formed along y and z, and this plane is your yz plane, and equation of yz plane will be simply x equals 0. Now this point, say F, it lies in yz plane, so its coordinate will be 0, y and z. And then if we take this point, which is, say this point P, now this point is x unit along x-axis, y unit along y-axis, and z units along z-axis. So coordinate of this point P will be x, y, z. So if we have any point P, x, y and z, its distance along x-axis is x, along y-axis is y, and along z-axis is z. Now if we find foot of perpendicular from P on xy plane. So foot of perpendicular from P on xy plane is this point E, and on xy plane z-axis is 0. So this point will be simply x, y, 0, and it is nothing but E. In the same way, if we find foot of perpendicular from P on yz plane, now on yz plane it is this F, and it will be given by 0, yz, and foot of perpendicular from P on xz plane. Now on xz plane, y coordinate is 0, and this point is D. It is x, 0 and z. Now it may also ask foot of perpendicular on the axis. So from this point P, if we drop a perpendicular on x-axis, it will be this point A. So foot of perpendicular from P on x-axis will be simply x, 0, 0, and will be this point A. In the same way, foot of perpendicular on y-axis will be this B, which is 0, y, 0, and on z-axis will be this point C, which is 0, 0 and z. And if we need to find length of perpendicular, say L, now in this case, this length of perpendicular will be z. Now on yz plane, length of perpendicular will be simply x, and on xz plane, this length of perpendicular will be simply y. Then the same way, we have to find length of perpendicular from P to A. Now we know that this is foot of perpendicular. So this length will be given by distance between x00 and xyz, which is nothing but, which is under root of y square plus z square. And here this length will be under root of z square plus x square. And this one, this length is under root of x square plus y square. So a quick recap. So any point on x-axis will be taken as x00, on y-axis will be 0y0, and on z-axis will be 0z. And then any general point in 3D space, it can be expressed as P xyz, where x is distance along x, y is distance along y, and z is distance along z. Now, foot of perpendicular from P on xy plane, it is xy0. On yz plane, it is 0yz. On xz plane, it is x0z. And foot of perpendicular from P on the axis, they will be simply intercepts x00, 0y0 and 00z. And we can find their respective lengths of the perpendicular also. Now we have any point P, which is xyz. Then we know that any point is nothing but a position vector. So this is any vector OP. Then we can write this OP as xi plus yj plus zk. Now suppose we have 2 points, say P, which is x1, y1, z1, and we have another point Q, which is x2, y2 and z2. Then we can write this vector PQ as position vector of Q minus position vector of P, which is x2 minus x1i plus y2 minus y1j plus z2 minus z1k. Now we find magnitude of PQ. Magnitude of PQ will be simply under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Now this PQ is nothing but distance between points P and Q. So in 3D geometry, we have this distance formula. Distance between 2 points P and Q, whose coordinates are x1, y1, z1, x2, y2 and z2, will be under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So if we are given 2 points, we can always find distance between them in 3D geometry. Now the next one is section formula. Now section formula is, suppose we are given 2 points P and Q. Now P is say x1, y1, z1 and Q is x2, y2 and z2. Then if we have any point A which divides PQ internally in the ratio m is to n. So this is internal division because A lies between P and Q. That means AP upon AQ, it is m by n. Then coordinate of this point A will be given by mx2 plus nx1 upon m plus n will be my2 plus ny1 upon m plus n, and the same way it will be mz2 plus nz1 upon m plus n, which is same as section formula in 2D except for the fact that we have this additional term for z coordinate. And in distance formula also, formula is same except that we have added this z term. Now if we have external division, so suppose we have 2 points P and Q again. Now this is P and this is Q. This is x1, y1, z1 and Q is x2, y2, z2. And then we have point A which divides P and Q in the ratio m is to n externally. That means now this point A, it lies outside of this line segment PQ. Now in this case AP upon AQ, it is again m is to n. Now coordinate of this point A will now be given by this mx2 minus n x1 upon m minus n. It'll be m y2 minus n y1 upon m minus n, and it'll be m z2 minus n z1 upon m minus n. Now, if there is any question where we are given 2 points, say P and Q, which are x1, y1, z1, x2, y2 and z2, and we need to find a ratio of some point A, then we'll consider this ratio as lambda is to 1. In that case, we'll write coordinate of this point A as lambda x2 plus x1 upon lambda plus 1, lambda y2 plus y1 upon lambda plus 1, and lambda z2 plus z1 upon lambda plus 1. Now say for example we are given 2 points 0, 0, 0, 1, minus 2, minus 5, and it says find the ratio in which line joining these points is divided by this plane, which is x minus y plus z equals 1. Now we are given 2 points, say P, which is 0, 0, 0, and Q, which is 1, minus 2 and minus 5. Now we need to find the ratio in which this plane, it divides this line segment PQ. Now let this point of intersection be A, and suppose this A, it divides PQ in the ratio lambda is to 1, then we can write coordinate of this A as lambda upon lambda plus 1 minus 2 lambda upon lambda plus 1, and then minus 5 lambda upon lambda plus 1. Now this point A, it lies on this plane, so it will satisfy equation of this plane. So we put the value of x, y and z here, we'll get lambda upon lambda plus 1 plus 2 lambda upon lambda plus 1 minus 5 lambda upon lambda plus 1, it is equal to 1. Now this is minus 2 lambda equals lambda plus 1. So value of lambda is simply minus 1 by 3. So this point A, it divides P and Q in the ratio 1 is to 3, and this minus sign indicates it is an external division. Now here the question is, a line passing through the points say P and Q crosses YZ plane at a point 0, 17 by 2 and minus 13 by 2. Now let this point be A, and it divides it in the ratio lambda is to 1, so we can write 3 lambda plus 5 upon lambda plus 1, b lambda plus 1 upon lambda plus 1, and lambda plus a upon lambda plus 1. Now it is given that this point is 0, 17 by 2 and minus 13 by 2. Now since this is YZ plane, its equation is x equals 0, and obviously this x, it has to be 0. Now we equate it to 0, we'll get the value of lambda as minus 5 by 3. Now if we put lambda as minus 5 by 3, here we'll get minus 5b plus 3 upon minus 2, it'll be 17 by 2. Now this is minus 5b equals minus 20. So value of b is 4. And if we compare this, we'll get minus 5 plus 3a upon minus 2, it'll be equal to minus 13 by 2. So we'll get 3a equals 13 plus 5, 18. 18 by 3 is 6. So value of a is 6 and value of b is 4, and that's your option D. Now using section formula, we can find various centers in a triangle. So if we have any triangle, say ABC, and this A is x1, y1, z1, B is x2, y2, z2, and C is x3, y3, and z3, then centroid of this triangle, it is given by x1 plus x2 plus x3 by 3, comma, y1 plus y2 plus y3 by 3, and z1 plus z2 plus z3 by 3. Now we can also find its incenter. Now if length of this side is A, length of the side is B, and here this length is C, then we can find incenter as ax1 plus bx2 plus cx3 upon a plus b plus c, and the same way we can write them for y and z coordinates. So it will be ay1 by2 cy3 upon a plus b plus c, and then az1 plus bz2 plus cz3 upon a plus b plus c. We can also find orthocenter. Orthocenter of this triangle. So if this angle is A, so if we know all the three angles A, B and C, then we can write orthocenter as x1 tan A plus x2 tan B plus x3 tan C upon tan A plus tan B plus tan C, and we'll repeat the formula for y and z, taking them as y1, y2 and y3 and z1, z2 and z3. So this is how we can find orthocenter. We can also use condition of perpendicular vectors to find conditions for orthocenter. So suppose this point is alpha, beta and gamma, then basically vector AH will be perpendicular to BC. That means vector AH dot BC, it must be 0, and the same way BH is perpendicular to AC. That means this vector BH dot AC, it must also be 0. So from these two conditions also we can find orthocenter of this triangle. And finally we can find circumcenter. And for circumcenter, again we need angles. So we can write this as x1 sine 2a plus x2 sine 2b plus x3 sine 2c upon sine 2a plus sine 2b plus sine 2c, and it will be same for y and z. We will replace x with y and z. So this is how we can find all the four centers in a triangle. And then there may be some questions on area of this triangle. And we know that area of triangle is given by 1 by 2 and then mod of cross product of any two sides. So we can take ABBC, ABAC or BCAC. So we'll find this cross product and take its magnitude and multiply it with 1 by 2. We can always find area of this triangle. And if we have a tetrahedron, say ABCD, then suppose this is x1, y1, z1, x2, y2, z2, x3, y3, z3 and x4, y4 and z4. Then center of this tetrahedron, it is given by x1 plus x2 plus x3 plus x4 divided by 4. In the same way, sum of all y coordinates divided by 4 and sum of all z coordinates divided by 4. And in vectors, we have already seen that volume of this tetrahedron, it is given by 1 by 6 into scalar triple product of any three coterminous edges. So let it be AB, AC and AD. And we can also find this volume as 1 by 3 into any one perpendicular distance, say this D, into area of this base triangle. So in this case, area of triangle BCD, we can find it in terms of any distance, and we can choose any of these four triangles as base triangle. Now we are given this triangle whose coordinates are 215, 323 and 404. Now let these vertices be A, B and C. Now if we find AB, AB will be, now this is 1 square plus 1 square plus 2 square, it is root 6. Now BC is under root of 1 square plus 2 square plus 1 square, it also is root 6, and CA will be 2 square plus 1 square plus 1 square, which is root 6. That means this triangle ABC, it is an equilateral triangle. And if the triangle is equilateral, then orthocenter and centroid in center, all the centers coincide. So in this case, orthocenter will be given by this centroid, and which is x1 plus x2 plus x3 by 3. So it will be 5 plus 4, 9. 9 by 3 is 3. 1 plus 2, 3. 3 by 3 is 1. And then 5 plus 4 plus 3, 12. 12 by 3 is 4. So orthocenter of this triangle is at 3, 1, 4. And that's your option 4. Now here are the questions. Let ABCD be a tetrahedron such that AB, AC and AD are mutually perpendicular. So what we'll do is, we'll assume, let this A be at origin, and then we have this tetrahedron ABCD. So this is B, C and D. Now if this is 0, we'll write this as B0, 0. Now this is 0, C0, and here it will be 0, 0 and D. Now it says, let area of triangles ABC. Now area of this triangle ABC, it is 1 by 2 BC, and it says it is X. Then area of triangle ACD. Area of triangle ACD is this triangle. So it will be 1 by 2 CD, which is Y. And then ADB. ADB is 1 by 2 BD, and it is equal to Z. Now it says find the area of triangle BCD. Now in order to find area of triangle BCD, we'll find vector BC. Vector BC is CJ minus BI, and we'll find BD, and BD is DK minus BI. Now we'll find their cross product BC cross BD. Now BC cross BD is this I, J, K, and here it is minus B, C, 0, and here will be this minus B, 0 and D. Now we solve this, we'll get CD into I plus BD into J plus BC into K. Area of this triangle BCD will be 1 by 2 into mod of BC cross BD. Now this is 1 by 2 and then under root of CD square plus BD square plus BC square. Now we'll take this 1 by 2 inside also, so we can write CD by 2 square plus BD by 2 square plus BC by 2 square, and this is nothing but under root of x square plus y square plus z square. Now the question is, 3 lines are given by r equals lambda I, r equals mu I plus j, and r equals v I plus j plus k. Now let the lines cut the plane x plus y plus z at points a, b and c. Now this point A is lambda 0, 0. Now B is mu and 0, and C is v and v, and they all lie on this plane x plus y plus z equals 1. Now here we'll get lambda is 1, so we'll get A as 1, 0, 0. Now for this B, we'll get 2 mu equals 1, or mu is 1 by 2. So this point B will be 1 by 2, 1 by 2, 0. And for C, we'll get 3v equals 1. So V is 1 by 3. So it will be 1 by 3, 1 by 3 and 1 by 3. So we have A, B and C. Now we need to find area of this triangle ABC. Now for this, what we'll do is we'll find this vector AB, and vector AB is minus 1 by 2i plus 1 by 2j, and we'll find this vector AC, and vector AC is minus 2 by 3i plus 1 by 3j and plus 1 by 3k. Now what we'll do is we'll find this cross product AB cross AC. Now it'll be this ijk, and will be minus 1 by 2 plus 1 by 2, 0, and this is minus 2 by 3, 1 by 3 and 1 by 3. Now from this second row we'll take 1 by 2 common, and from this third row we'll take 1 by 3 common. So we'll get 1 by 6, and here will be this I, J, k. This is minus 1, 1, 0. And this is minus 2, 1 and 1. Now we solve this cross product, we can write AB cross AC as 1 by 6. Now this is I plus j and plus k. Now if we find area of this triangle is 1 by 2 mod of AB cross AC. Now it will be this 1 by 2 and then 1 by 6 into mod of I plus j plus k is simply root 3. Now if we square it, we can write 6 delta whole square will be equal to 3 by 4, which is 0.75. Now here the question is, if origin is orthocenter of triangle formed by the points cos alpha sin alpha 0, cos beta sin beta 0 and cos gamma sin gamma 0. Now let these points be A, B and C. Now if we find OA, then OA is under root of cos square alpha plus sin square alpha plus 0, which is 1. In the same way, OB is 1 and OC is 1. So this O, it is also circumcenter of this triangle ABC. Now it is given that origin is orthocenter and we have worked out origin is circumcenter. That means this triangle ABC, it is an equilateral triangle. Now since all the z coordinates, they are 0. So basically we can consider this triangle in xy plane lying along a unit circle with center at origin and radius as 1 unit. So we have 3 vertices A, B and C, and it is an equilateral triangle with center at origin. So suppose this is x-axis, so we'll make an angle alpha. Now this will make an angle beta, and here it'll make an angle gamma. Now beta minus alpha, it is 120 degrees. Gamma minus beta, it is also 120 degrees. And this angle, which is alpha, and this is 2 pi minus gamma. So alpha plus 360 minus gamma, it is also 120 degrees. So from here we'll get alpha minus gamma as minus 240. Now if we subtract this first from third, we can write 2 alpha minus beta minus gamma will be equal to minus 360. If we subtract second from first, we'll get 2 beta minus gamma minus alpha will be 0. So all these angles, they'll be either 0 or 360 degrees. So this cyclic summation will be simply 1 plus 1 plus 1, and that is 3, and that's your option 4. Now the question is, we have this rubber cube C in the first octant, and this is origin. This is suppose x-axis, y-axis and z-axis. Now this is 1, 0, 0. This is 0, 0 and 0. This point is 0, 1, 0. This is 0, 0 and 1. This is 1, 1, 0. This is 1, 0 and 1. This is 0, 1, 1. This point is 1, 1 and 1. And their diagonals, they'll all intersect at 1 by 2, 1 by 2 and 1 by 2. Now this first part is we have made a cut by a sharp knife along the plane x equals y. Now x equals y, it'll pass through origin. It'll pass through this point 1, 1, 1. It'll pass through this 1 by 2, 1 by 2, 1 by 2. And it'll pass through this 1, 1, 0. And it'll also pass through this 0, 0, 1. So we have made this cut along this plane. So now we have divided this entire cube in 2 parts. Now we have made the second cut along y equals z line. Now along y equals z, we have this point we have this point 0, 0, and this point, so it will be this and this, and we have made a cut along this plane. So now we have made it into 4 pieces, and now finally we have made this final cut along z equals x line. Now z equals x will pass through 0, 1, 0, it'll pass through origin, it'll pass through 1, 0, 1, and it'll pass through this 1, 1 and 1. So it'll be along this section. Now if we slice it along this section, these two parts at the top and at the bottom will be divided into 2. So total number of such pieces will be simply 6. And that is the answer to this question.